Let's look at a finite geometric sum. So you might remember from section 9.1 that a geometric sequence has the form C, our base term, times r to the n, where r is our common ratio. So you might not have recognized this, but hopefully you did from the example we just did, that this is a geometric series. So we have our term of C is equal to 250. So you see a 250 in each of these. And then our common ratio r is this 4%. So I have 4% cubed, 4% squared, 4% to the first, and then this would be 4% is 0. All right, so our geometric sum is going to be represented by a capital S with a subscript of a capital N. And so that finite sum involves adding up the capital N plus 1 terms. So I can take this CR to the N, and I'll put a summation sign in front of it. So I'm adding up the terms, and it's going to go from little n equals 0 to big N. All right, so my Sn is going to be n equals 0, gives me a C, plus when n equals 1, I get CR, plus when n equals 2, I get CR squared, all the way out to CR to the N. And then what I'm going to do is I'm going to write down another copy of Sn, and I'm going to multiply it by r. So the C becomes a CR, the CR becomes a CR squared, plus all the way out to CR to the N, plus CR to the capital N plus 1. And then what I'm going to do is I'm going to subtract r times Sn from Sn. So I'm going to subtract this whole line here. And that gives me Sn minus r times Sn is equal to C, and then the CR's cancel, the CR squareds cancel, everything cancels until I get to the very end here. And then remember that I have a minus sign here, so this will be minus CR to the capital N plus 1. Right, I'm going to factor both sides. So on the left I'll factor out an Sn, and I get 1 minus r, and on the right I'm going to factor out a C, so I get 1 minus r to the capital N plus 1. And then to solve for Sn, I get C times 1 minus r to the capital N plus 1 divided by 1 minus r. And I can sum all that up in this box. So the formula for this sum of a finite geometric series, so if Sn is equal to C plus CR plus CR squared, all the way out to plus CR to the capital N. So that's the sum from little n equals 0 to big N of CR to the little n, which is equal to C times 1 minus r to the capital N plus 1 divided by 1 minus r.